Hello, this is Algebra 1, Lesson 67, Saxon Math. In this lesson, we're going to talk about a review of equivalent equations and learn a new way of solving systems of equation called elimination. So the first thing, let's review what equivalent equations are. They're equations that have the same solution. So let's solve this. When we solve this, we get the solution x equal 2 on this equation. When we take this equation here and we solve it, we actually get 2 as well. When we put it back in, we check it, we get the same answer. However, they are not equivalent because this one has two solutions. It has a plus or minus. So, therefore, they're not the same equations. And if you look at them, this is x plus 4 and this is x squared minus 4. They do have one solution in common, but that's it. So, but these equations, so remember that if every term of a particular equation is multiplied by the same non-zero quantity, then the result of the equation is equivalent. Okay, so it's equivalent to the original equation. So for instance, let's look at the equation x plus y equals 6. If we multiply every term, the entire equation, by 2, we're going to get 2x plus 2y equals 12. This equation is equivalent to the original equation because we multiplied everything by 2. If we take the ordered pair 4, 2, let's see if it makes this equation true. Okay, it works for the first one. Now what about the second one? So 2 times 4 plus 2 times 2 equals 12. Let's see, does 8 plus 4 equal 12? Yes, 12 equals 12. So they're both true. They have the exact same equation. So saying that, we're going to use this information to look at the next procedure for solving systems of equations. So remember, systems is where we have two equations and we're trying to find a solution, an xy coordinate, that satisfies both equations. This process is called elimination. So we already learned graphing. Now we're going to learn elimination. So let's take this equation, x plus 2y equals 8 and 5x minus 2y equals 4. Okay, this is our system of equations. So before we would solve for x or y and then substitute back in. So now we're going to keep it in standard form. X's line up with the x's, the y's with the y's, and the constants on the other side of the equal sign. So what we're trying to do is we're looking at the variables and we're looking at their coefficients. We're looking for opposite coefficients. We have a positive 2, minus 2, positive 1, positive 5. These two have opposite coefficients. So now we can simply just add the two equations together. Anything plus its opposite is 0. X plus 5x is 6x equals 12. Now we can eliminate, we've eliminated one of the variables. Now we can divide by 6, we get x equal 2. Then we put it back in to one of the equations and we solve, and y equals 3. So our solution here is going to be x equal 2 and y equal 3. All right, and we can put it back in there and check it to make sure we have the same thing. So let's try the next example, 67.1. They want us to solve by using elimination. So we said the first thing we want to look for is we want to look at the coefficients of the variable. Do we have any opposites? We've got 2 and 3 here, not opposites. Negative y and positive 4, not opposites. So let's go ahead and give these equations names. I use alphabet, but you can use numbers, you can use symbols, whatever you want, just to identify what we're talking about. All right? So I don't have any opposite coefficients. So what I need to do is I need to make them opposites. The easiest one to do is here, the sign's already opposite, and this is an implied 1, correct? And this is 4. So if I multiplied this equation, this term by 4, it would be -4, which would make it the opposite of +4. So, but to do that, I have to do it to the entire equation. So, instead of trying to squeeze it in here, rewrite it, 8x minus 4y equals what, 2652? Okay. And then we rewrite the second equation. Let's not get lazy here because what will happen is we'll forget something and we'll mess up. So again, this is equation A and equation B. So when I add them, I get 11x. This cancels out and this becomes 55x. Now I divide by 11, I get x equal 5. So now how do I find y? Well, I'm going to put it into one of the equations. So 2 times 5 minus y equals 13. That's 10, so minus 10, negative y equals 3. Divide by -1 and y equals -3. So my solution here is going to be 5, -3. Let's do another one. Okay, so we're all doing nothing but elimination. Sometimes you have to multiply both equations. So here my coefficients are 2 and 3, -3 and +4. Now my signs are opposite. However, these two numbers are not the same. And if I had one, either -1 or +1, it'd be real easy. Then we would just multiply one of the equations by whatever the other coefficient is. So basically, we're getting a least common multiple between the coefficients. Now, I can choose these already opposite, but the least common multiple is 12. I would have to multiply equation A by 4 and equation B by 3. Not a problem. And actually, that would be no big deal. But 2 and 3 are smaller, and I've got 18 over here. So let's see what the book did. The book multiplied A by -3 and B by 2 because the least common multiple for 2 and 3 is 6. So what do I need to multiply 2 by to get 6? -3 and 3 by 2 to get +6. Now, I could have multiplied this by +3 and this by -2. It doesn't matter. One of them has to be negative because they're both the same sign. I need them to be opposite. So remember, I distribute to the entire equation. So I get -6x plus 9y equals -15. Then I get +6x plus 8y equals -36. So now I'm going to add the two equations, and this cancels a 0. This is 17y equals, let's see, 1151, so -51. Then I divide both sides by 17, and I get y equals -3. Now to find x, I go back and I plug it into one of the equations. So 2x minus 3 times 3 equal 5. This is -9, so I'm going to add 9 to both sides. And I get 2x equal 14, divide by 2, and I get x equals 7. Okay, and my solution, I write it x comma y in a coordinate form. That's your solution. Oops, I must have done something wrong. Plus, oh, this was a, oh, my mistake. This is -3. -3 makes it positive, so we're going to subtract 9. Subtract 9, which gives us -4, which gives us x is -2. And if I would have checked this into the other equation, I would have found out that that I had a wrong solution. So let's do the next example, 67.3. So we have 2x minus 3y equal 5. Oh, so they're just doing it again, but now they're eliminating the y's. Okay, so remember we could do whatever we want to do. Yes? We just have to do it to use the rule properly. So now we're getting rid of the y, so we're going to multiply this one by 4 and this one by 3. So we're going to get 8x minus 12y equal 20. 9x plus 12y equal, what is 18 times 3? Negative 54. Okay, now we add the equations. We get 17x equal negative 34, and divided by 17, we get x's, we get the same answer, negative 2, and we put it back in, we'll get the same thing for y. So it doesn't matter which one, we just got to make sure we use a property and label. So let's try this last one together. 2x plus 5y equals negative 7. Then we have 3x minus 4y equal 1. All right, so what do we want to get rid of? We don't want to get it, so the x's or the y's. So let's look at our coefficients. Are 2 and 3. The least common multiple is here is 6. The least common multiple here is going to be 20. So we'd have to multiply this one by 4, this one by 5. Those are bigger numbers. So I just personally will choose the smaller one. So I'm going to multiply equation A by 3. Okay, the book does it a little different. And I'm going to multiply this by negative 2. So then we get 6x plus 15y equal negative 21. Then I'm going to get negative 6x plus 8y equal negative 2. These cancel. This becomes 3 and 1. So 23y equal negative 23 and y equal negative 1. Plug it back in. 3x minus 4 times negative 1 equal 1. That's plus 4, so we're going to minus 4 from both sides. 3x equal negative 3 and x equal negative 1. So my solution is negative 1, 1. Now remember, you always got to go back. Since I put it in this one, I'm going to check it in this one to make sure I get a true solution. Stop the video and do the practice problems, and we'll see you at the next class.